Welcome to the presentation about the project Defect-Free Design. My name is Lucy Binke and I'm the project lead. In the coming minutes, I will share with you why defects are so critical for ASML and what you can do to prevent defectivity issues on ships. As ships are made from sand, let me take you with me on a beach walk. So one day I was walking on the beach. Can you feel the sand under your feet walking on the sand? Can you hear the waves? Oh, I felt so happy and relaxed. But suddenly, I felt something different on my foot. I stepped on a black oily puddle. I looked down to my foot and it was completely dirty. So I needed to walk home immediately to clean it. Can you imagine how angry I felt? That is how angry our customer feel when a particle lands on a chip. But there are ways to prevent it. I will show you how defects can be prevented during the design phase and what Google Maps has to do with it. I will show you that it's most effective when learnings are structurally implemented in the design phase. And as Einstein said, the only mistake in life is the lessons not learned. So what do we mean with defects? Imagine a particle lands on the wafer or on the radical and is printed, as you can see here. The result is a defect chip. And when we look closer, we understand why. Even so, the size of the particle is in nanometer range, so it's really small. Compared to the printed structure, it's big. If the particle falls onto it, it breaks the electron flux and the chip is defect. That is why our customer says the smallest defect results in inferior products and it costs millions of euros. Where do the particles come from? Unfortunately, they can be from everywhere in the machine. I will give you a few examples. During the rapid movement of the cables, due to wear, particles are generated. Also, during cleaning actions, fiber sticks around sharp edges. Another example is that during tightening of bolts, metal particles get loose. But all of these above-mentioned examples can be solved. Even better than solving is to prevent and embed the learning in the design. You can see here the V model, from the bright idea to the complete machine. We write down specification and tests. And if something is new, learned, the knowledge is shared with the technical competences. And from their documentation, it goes back into the design. And we close the feedback loop. What did we learn already? In the beginning of the design, it's important to ask where could particles come from? Here, where do they hide? How to avoid play and slip? What materials are allowed? And what is the cleanness grade? The next question is, what is the particle path? How can I verify? And how can we block particles mechanically or also by flow? That are all good questions to be answered during the design process. That holds also for the manufacturing process. Here are some concrete examples how to prevent particle generation. The cables are fixed with brackets to avoid slip. Also, it follows the shape of the cables. To reduce friction, the surface roughness is reduced by polishing the mirrors and also add tape to the components. Another important topic is to ensure proper packaging, so the part cannot move during transport and generate particles. It is difficult to prevent fully the generation of particles, so the further transport needs to be blocked. An example is the defectivity cover plate to protect the reticle. And talking about general, when you have moving parts, think about shielding. And talking about moving, when parts are transported, keep them at a minimum height of 50 centimeters above the floor so no particles are added. If the part gets dirty, the next option is to clean the part. Let's make the parts dirty. Everywhere are particles. Now, it's much easier to clean with round edges and big ruddy. That takes more to manufacture, but it pays off. And the part can be really complex with multiple cleanliness grades on it. And to easily understand the requirements, the next step is to bring the cleanliness grade in the 3D model. You can compare it on the paper map to Google Maps. I'm sure every one of you uses Google Maps to get around in unknown places. If you're really hungry and you want to get the best fries in the region, you want to go there as fast as possible. So the cleanliness grades in 3D model will enable shorter design and manufacturing cycles. I hope now you understand why defects are so critical for ASML and how to prevent, and that it's the most effective way to close the feedback loops when learnings are structurally implemented in the design phase. Thank you, and enjoy soon a walk on a wonderful beach.